Good day, students. Welcome to this JSS 1 Basic Technology lesson on basic geometric constructions. Geometric constructions are procedures for drawing precise geometric shapes using only a compass and straight edge ruler, used only for measuring, not for drawing freehand lines. These constructions form the foundation of technical drawing and are also tested in your mathematics classes. By the end of this lesson, you will be able to bisect a line segment, construct a perpendicular to a line, bisect an angle, construct specific angles, 60 degrees, 90 degrees, 45 degrees, 30 degrees, using compass and straight edge, and construct basic geometric shapes, equilateral triangle, regular hexagon. Let us begin. Key terms. Construction, a geometric figure drawn using only a compass and straight edge, without measurement, in pure geometry. In technical drawing, we also use measurements. Bisect, to cut or divide exactly in half. Perpendicular, at exactly 90 degrees to a line. Bisector of a line, perpendicular bisector, a line at 90 degrees that passes through the midpoint of the original line. Bisector of an angle, a line that divides an angle into two equal halves. Locus, the part of a point that moves according to a given rule. Tools used. Compass, for arcs, ruler/steel rule, for measuring and drawing straight lines, sharp pencil, H or 2H for construction arcs, HB for final lines. Construction 1, bisecting a line segment up. Given line segment AB. Step 1, open compass to more than half the length of AB. Step 2, place needle at A. Draw an arc above and below the line. Step 3, without changing the compass setting, place needle at B, draw arcs above and below the line and cutting the arcs from step 2. Step 4, the two intersection points, one above, one below, define the perpendicular bisector. Step 5, draw a straight line through these two intersection points. This is the perpendicular bisector of AB, it passes through the midpoint M of AB. Construction 2, erecting a perpendicular from a point on a line. Given line XY with point P on the line. Step 1, with needle at P, draw arcs cutting the line on each side points A and B. Step 2, with needle at A, compass open wide, draw arc above the line. Step 3, with same setting, needle at B, draw arc crossing the one from a point C. Step 4, draw line PC. This is perpendicular to XY at P. Construction 3, bisecting an angle. Given angle BECE. Step 1, place needle at vertex A, draw arc cutting AB at P and AC at Q. Step 2, place needle at P, draw arc in the interior of the angle. Step 3, without changing compass setting, place needle at Q, draw arc crossing arc from P point A. Step 4, draw line AR, this is the angle bisector of angle BECE. Construction 4, constructing a 60 degrees angle. A 60 degrees angle can be constructed using the fact that an equilateral triangle has all angles equal 60 degrees. Step 1, draw a baseline. Mark point A. Step 2, open compass to any radius R. With needle at A, draw a large arc cutting the baseline at B. Step 3, with same radius, needle at B, draw arc cutting the first arc at C. Step 4, draw line AC. Angle BECE equals 60 degrees. Construction 5, constructing a 90 degrees angle. Use the perpendicular construction above, perpendicular bisector or perpendicular from a point. Construction 6, constructing 45 degrees. Construct 90 degrees first, then bisect the 90 degrees angle gives two 45 degrees angles. Construction 7, constructing 30 degrees. Construct 60 degrees first, then bisect it gives two 30 degrees angles. Construction 8, equilateral triangle, all sides equal, all angles 60 degrees. Step 1, draw baseline AB of the desired length. Step 2, with radius equals AB, needle at A, draw arc above the line. Step 3, with same radius, needle at B, draw arc intersecting the first point C. Step 4, Draw lines AC and BC. Triangle ABC is equilateral. Construction 9. Regular hexagon, 6 equal sides, all interior angles equals 120 degrees. Using a compass and circle method. Step 1. Draw a circle of radius r. This will be the side length of the hexagon. Step 2. Mark any point A on the circle. With the same radius r, step off arcs around the circle from A, marking points B, C, D, E, F. Step 3. Connect ABCDEFA with straight lines regular hexagon. This works because the radius of a circle exactly fits 6 times around the circumference when the chord equals the radius. Construction 10. Dividing a line into equal parts. To divide line AB into 5 equal parts. Step 1. Draw a line at an angle from A. Step 2. Mark off 5 equal lengths along this new line using compass or ruler A1, A2, A3, A4, A5. Step 3. Connect A5 to B. Step 4. Draw lines parallel to A5B from each marked point. These cross AB and divide it into 5 equal parts. 3 examination questions. Question 1. How would you construct an angle of 30 degrees without a protractor? Step 1. Construct a 60 degrees angle using the equilateral triangle method, arcs of equal radius from endpoints of a base. Step 2. Bisect the 60 degrees angle by placing compass needle at the vertex, drawing an arc cutting both sides of the 60 degrees angle, then with equal compass settings, drawing arcs from each intersection point and connecting their crossing point to the vertex. The bisector divides 60 degrees into 30 degrees plus 30 degrees. Question 2. Describe how you would find the midpoint of a line segment PQ using only a compass and ruler. Open compass to slightly more than half PQ. From P, draw arcs above and below the line. Without changing the compass, from Q, draw arcs above and below cutting the previous arcs. Draw a line through the 2 intersection points. This line crosses PQ at its exact midpoint M. Question 3. Why do we use a compass for geometric constructions rather than a protractor? Compass constructions are theoretically exact. They do not depend on the accuracy of printed markings or the reader's ability to read fine degree graduations. A protractor always has some reading error. For precise technical work, constructions ensure mathematical exactness, especially when working at large scales on drawing boards. 3 common mistakes. Mistake 1. Changing the compass radius between steps that require the same radius. In bisection constructions, you must keep the same compass setting when drawing arcs from both ends of the line. If you accidentally change the radius, the arcs will not intersect correctly and your bisector will be wrong. Set the compass and do not touch the adjustment until instructed. Mistake 2. Not drawing construction arcs large enough. Arcs must be big enough to intersect clearly. Tiny arcs that barely cross are hard to see and introduce inaccuracy. Draw generous arcs. Mistake 3. Pressing the compass needle so hard it makes a large hole in the paper. The needle should leave only a tiny pin mark, a small center that holds the compass steady, not a gaping hole. Press gently and firmly. Summary. Geometric construction, precise drawing using compass and straight edge. Key constructions: perpendicular bisector of AB, arcs from A and B, connect intersections, perpendicular from point on line, arcs from point, then from both sides, angle bisector, arc from vertex, then arcs from both sides of angle, connect, 60 degrees angle, equilateral triangle method, 90 degrees, perpendicular, 45 degrees equals bisect 90 degrees, 30 degrees equals bisect 60 degrees, equilateral triangle, equal arcs from each end of base, regular hexagon, radius equals side, step of a round circle. Dividing a line into equal parts, angle and parallel method. Never change compass radius between steps requiring the same setting. For homework, A. Bisect a line segment of 8 cm, B. Construct angles of 60 degrees, 30 degrees, and 45 degrees, C. Construct an equilateral triangle of side 60 mm. Attempt the quiz on your LMS. Precision in drawing leads to precision in making. Visit Litech Academy at academy.litech.com.ng. Until next time.